For 4.5 billion years, the moon has orbited our planet. Its gravitational pull drags our oceans back and forth to create the tides, and its massive weight anchors Earth's axial tilt, keeping our seasons predictable and our climate stable. Now imagine an invisible hand reaches into our orbit. Without warning, our companion is violently ripped away into the darkest reaches of the solar system. Look at these brightly lit coastlines. Without the moon's gravity pulling on our oceans, those familiar tides immediately shrink by 2/3. Without its anchor, our planet begins to wobble on its axis, like a dying spinning top, throwing global weather patterns into absolute chaos. But an unraveling climate is a slow problem. Out in the cold void, the displaced moon is rocketing towards an immediate, violent, physical doom. Look at this surface. The moon is essentially a massive ball of cold rock and iron. It has zero atmosphere. There is no protective layer of gas to cushion a blow. It is a naked, exposed rock wandering into hostile territory, and its target is Jupiter. This gas giant is essentially a failed star. It is a swirling, boundless sphere of hydrogen and helium, so massive that you could pack 1,300 entire Earths inside of it. Because Jupiter is composed entirely of gas, there is no solid ground to strike. An incoming object does not crash. It simply falls, sinking endlessly into a dark, crushing abyss. As the moon approaches, Jupiter's massive gravity well acts like a cosmic tractor beam. It pulls the massive sphere in, accelerating it to terrifying speeds. This is what happens when a solid object is forced to fight an infinite atmosphere. It is the ultimate cosmic execution. The assault begins thousands of miles before the moon even touches the clouds. Jupiter possesses a magnetic field 20,000 times stronger than Earth's, blasting the incoming rock with lethal, highly charged radiation. As it closes in, the moon crosses a boundary called the Roche Limit. Because Jupiter is so massive, its gravity pulls significantly harder on the front edge of the moon than it does on the back. A looser clump of asteroids would shatter instantly here, but the moon is heavily compacted rock. It fights back. The extreme tidal forces stretch the sphere, warping it and triggering massive, violent moonquakes deep inside the iron core. By holding on to its structural integrity, the solid rock survives the gravity well, plunging toward the upper ammonia clouds at roughly 130,000 miles per hour. But surviving the gravitational stretching is only a temporary victory. The moon's stubborn resistance has just guaranteed its entry into a much more violent thermodynamic meat grinder. At 130,000 miles per hour, hypervelocity physics takes over. The moon is traveling so fast that the Jovian hydrogen and helium gases physically cannot get out of the way in time. Instead, they violently compress against the leading edge of the rock. In fluid dynamics, extreme compression generates extreme heat. This creates what physicists call a plasma bow shock. The compressed gas in front of the moon rapidly ignites into a blinding, superheated shield. Look at the sheer thermal energy of these solar flares. The gas trapped in front of the falling moon is currently burning hotter than the surface of the sun itself. The moon instantly transforms into a brilliant, screaming fireball. The intense heat physically boils the outer layers of the lunar rock, vaporizing silicate and tearing a temporary continent-sized hole right through the upper cloud decks. The gas is burning the rock, but heat isn't the primary weapon. The thickening atmosphere acts as an unyielding, infinite brick wall, rapidly dragging the speeding moon to a halt. The moon plows hundreds of miles deep, passing through the brownish ammonium clouds and sinking into Jupiter's dark red water layer. Down here, atmospheric pressure doubles, then triples, multiplying exponentially. The sheer drag forces are catastrophic. Pushing against millions of Earth atmospheres of pressure, the structural integrity of the solid rock finally buckles. The entire moon fragments into a chaotic swarm of colossal molten boulders. Each individual boulder slams into the thick gas, detonating with massive kinetic energy. The total fragmentation releases a shockwave that dwarfs the combined explosive yield of every nuclear weapon ever built on Earth, multiplied by 1 billion. But the densest part of the moon keeps sinking. About 10,000 miles down, the environment becomes entirely alien. The pressure is so crushing that hydrogen gas is squeezed until it behaves exactly like a liquid metal, swirling at 36,000 degrees. The absolute center of our companion, its heavy iron core, plunges into this ocean of metallic hydrogen. The extreme temperatures melt the iron, slowly dissolving it until it fully mixes into the deep, turbulent liquid. The king of planets has successfully digested a 73 quintillion-ton celestial body. There is absolutely no solid evidence left behind. If you were to point a telescope at Jupiter right after this collision, you would see a massive, terrifyingly beautiful glowing vortex of vaporized rock and turbulent gas, marking the moon's temporary grave. But the visual is brief. The relentless 300-mile-per-hour winds raging across Jupiter's surface will churn and blend the gases, completely erasing the apocalyptic scar in less than a year. The gas giant simply absorbed the moon's entire mass, dispersing the iron and silicate as invisible trace elements. To a planet this massive, swallowing a moon doesn't even add a noticeable amount of volume. It is an extreme reminder of exactly where we live. This image captures just a fraction of the Milky Way, proving that the universe is unbelievably vast, brutally indifferent, and operates on scales of violence that easily erase whole worlds. But there is a counterweight to that dark reality. A fragile, carbon-based life form sitting on a wet rock managed to look up at the sky, calculate the mass of these planets, and visualize the physics of a metallic hydrogen ocean. The cosmos operates on a scale of indifferent destruction, but as long as we maintain our curiosity, as long as we keep asking, what if, our ability to understand that destruction makes our existence the most fascinating anomaly in the dark.
If this journey blew your mind, hit that like button and share it with your fellow explorers. Your support keeps this universe expanding.
Subscribe to join our mission. Now tell us, what mystery should we decode next? Let us know in the comments below.